This lesson 4.6 will finish out chapter 4. We are going to be talking about Cramer's rule. We're going to be using a lot of our previous knowledge about finding the determinants of matrices in this lesson. Cramer's rule is a technique used to solve systems of equations, one variable at a time. It involves putting the elements of each equation down a row or column in a matrix and solving each variable by finding multiple determinants. The best way for you to learn this method is to do examples. So the first example we're going to do pretty slow. The steps are going to be written underneath of it, so in your notes you need to write the steps out and then show the example that we're doing. And then we'll do one other example just a regular way, and then you guys will be free to work on your assignments. So the first example is a system of equations, and instead of using elimination or substitution, we're going to use Cramer's rule to solve it. And once you get the hang of this, this is easier than elimination and substitution. So it says, given the following system of equations, solve for the variables. So we need to figure out what x is and what y is. So we're going to do that using Cramer's rule. Step 1 of Cramer's rule says fill in the coefficients of each variable into our matrix. So I'm going to have a matrix here, and I need to fill in the coefficients, and I'm just going to put them in. The x's in the first column and the y's in the second column. So it's going to be 3, 5, -4, -8. Do not include the equal signs and the numbers to the right. And it says find the determinant of the original matrix. So in order to find the determinant, remember we multiply across the diagonals. So 3 times -8 minus 5 times -4. And I need to simplify. 3 times -8 is -24. And -5 times -4 is +20. -24 plus 20 is -4. And we're going to call this D. D is my original determinant. Okay, step 2 says we need to solve for x. In order to do this, we must take out the entire first column. So that's the 3 and the 5, which are the x's, and replace it with the numbers to the right of the equal sign. So to the right of the equal sign is 7 and 9. So I need to set up a new matrix, and I'm going to put 7 and 9 in the x column. And I'm going to leave the y's by themselves. So -4 and -8 are going to stay. Okay, once you've exchanged the two columns, find the determinant, and we are going to call this dx. So I'm going to multiply across the diagonal, 7 times -8 minus 9 times -4. Okay, 7 times -8 is -56. -9 times -4 is +36. And I need to add those together, and I'm going to get -20. And this is dx. Okay, step 3 says to finish solving for x, we must take dx and divide it by the original determinant d. This is the value of x, so x equals dx over d. And we actually have numeric values for that. So dx is -20. And if we scroll up here, my original determinant was -4. -20 divided by -4 is 5. So x equals 5 in this problem. Step 4 says repeat to solve for y. So I'm going to do the same process I just did, except this time I'm going to leave the x column alone. So 3 and 5. And I'm going to take out the y column and replace it with 7 and 9. And I'm going to find the determinant. 3 times 9 minus 5 times 7. 3 times 9 is 27. And -5 times 7 is -35. 27 minus 35 is -8. And this is going to be dy. And then to solve for y, it's going to be dy over d. dy was -8, d was -4. -8 divided by -4 is 2. Okay, and then it says write your answer as an ordered pair. So my x value was 5, and my y value was 2. So my answer is 5, 2. All right, let's do another example. I've got 3y plus x equals 5 and negative 7x equals negative 11 minus 9y. So the first thing that I noticed when I'm looking at this problem before I can even start is that things are out of order. So I need to have the x's first, the y's second, the equal signs, and then the whole numbers. So up top, I just need to switch things around. So I'm going to change it to be x plus 3y equals 5. And then on the bottom, I need to move this 9y over to the other side, and I need to do that by adding. So I'm going to get negative 7x plus 9y equals negative 11. Now I can go ahead and start solving. So my original determinant is going to be 1, negative 7, 3, and 9. And then I need to solve, so I'm going to multiply the diagonals. 1 times 9 minus 3 times negative 7. 1 times 9 is 9. Negative 3 times negative 7 is 21. 21 plus 9 is 30. So my original determinant is 30. Now I need to start solving for dx. So dx, I'm going to take the x column out and I'm going to replace it with my constants. So 5 and negative 11. And then the 3 and the 9 stay. And I need to define the determinant. 5 times 9 minus 3 times negative 11. 5 times 9 is 45. Negative 3 times negative 11 is positive 33. And if I add those together, I'm going to get 78. And to solve for x equals dx over d. So dx was 78 and d was 30. I know that 30 isn't divisible by, or 78 isn't divisible by 30, but it can probably be reduced. And that is going to be 13 over 5. Okay, and then I need to repeat that process for finding y. So this time the x column is going to stay 1 and negative 7, and the 3 and 9 are being changed out for 5 and negative 11. So find the determinant. 1 times negative 11 minus 5 times negative 7. 1 times negative 11 is negative 11. Negative 5 times negative 7 is 35. Negative 11 plus 35 is 24. All right, now we need to find y. That's going to be dy over d. dy was 24 and d was 30. Now I need to reduce. Those are both divisible by 6. 24 divided by 6 is 4. And 30 divided by 6 is 5. And the final thing I need to do then is write it as an ordered pair. So x is 13 over 5 and y is 4 over 5. Okay, and your homework can be found on Google Classroom.